welcome to section 6.2, area between curves. Our goal today is to find the area between two curves. The theorem we'll be using is if f and g are continuous and f of x is greater than or equal to g of x over an interval a to b, then the area bounded by f of x and g of x between this interval is given by the integral from a to b of the difference between f of x and g of x. We'll take a look at some examples of that here in a minute. And our definition of the Gini index of income concentration, if y is f of x, is our equation of a Lorenz curve, then the index is 2 times the integral from 0 to 1 of x minus f of x. In problems 1 through 7, find the area bounded by the graphs of the indicated equations over the given interval. Compute answers to 3 decimals if necessary. Okay, we have y equals 8x cubed minus 2, y equals 0, and our interval is between 0 and 6. So let's start by setting y equal to 0. So we have 8x cubed minus 2 equals 0. We'll have 8x cubed equal to x cubed equals 1/4. So x is going to be, if we rationalize our denominator by taking the cube root, we'll have the cube root of 2 over 2. And so, using our theorem, the integral from 0 to the cube root of 2 over 2 will give us 0 minus 8x cubed minus 2 dx. We'll be adding the integral from the cube root of 2 over 2 to 6. That way we cover our whole interval. This is going to be the 8x cubed minus 2 minus 0 dx. And so we will have from 0 to the cube root of 2 over 2, negative 8x cubed plus 2 dx plus the integral of the cube root of 2 over 2 to 6 of 8x cubed minus 2 dx. If we take the antiderivatives, we'll have negative 2x to the 4th plus 2x evaluated from 0 to the cube root of 2 over 2 plus 2x to the 4th minus 2x evaluated from the cube root of 2 over 2 to 6. If we evaluate, then we'll have 2 times the cube root of 2 over 2 to the 4th minus 2 times the cube root of 2 over 2 plus we'll close that one, we'll open this one, 2 times 6 to the 4th minus 2 times 6 minus 2 times the cube root of 2 over 2 to the 4th minus 2 times the cube root of 2 over 2. Okay, make sure you're keeping track. When we evaluate, remember we are subtracting, but in this case we are adding 2 different integrals together. And so we'll end up with 2,592 minus 12, which will give us the final area of 2,580. Y equals negative 2x cubed plus 9 and y equals 0. Our interval is negative 3 to 2. Okay, so let's negative 2x cubed plus 9 equals 0. That is negative 2x cubed equals negative 9. So x cubed equals 9 over 2. That gives us an x of the cube root of 9 over 2. So our area will give us the integral from negative 3 to the cube root of 9 over 2 of negative 2x cubed plus 9 minus 0 dx. And then we'll add the integral from the cube root of 9 over 2 to 2 of 0 minus negative 2x cubed plus 9 dx. And so if we simplify, we'll have the integral from negative 3 to the cube root of 9 over 2 of the negative 2x cubed plus 9 dx plus the integral from the cube root of 9 over 2 to 2 of 2x cubed minus 9 dx. Taking the antiderivatives, we'll have negative x to the 4th over 2 plus 9x evaluated from negative 3 to the cube root of 9 over 2 plus, finding the antiderivative of this one, x to the 4th over 2 minus 9x evaluated from the cube root of 9 over 2 to 2. Once we evaluate, then we've got negative cube root of 9 over 2 to the 4th over 2 plus 9 times the cube root of 9 over 2. And that is minus negative 3 to the 4th over 2 plus 9 times negative 3. And then we add the second one. If we evaluate this second one, we've got negative 2 to the 4th over 2 plus 9 times 2 minus negative cube root of 9 over 2 to the 4th over 2 plus 9 times the cube root of 9 over 2. Okay. And so this will give us 81 over 2 plus 27 plus negative 8 plus 18, which is 67.5 plus 10, and finally an area of 77.5 between these two curves. Y equals 8e to the x minus 5 and y equals 0, and then our interval will be from 0 to 2. So if we do our area, it will go from 0 to 2 of 8e to the x minus 5 minus 0 dx. And so our integral from 0 to 2 will be of 8e to the x minus 5 dx, which evaluated the antiderivative, 8e to the x minus 5x from 0 to 2. We'll have 8e squared minus 5 times 2 minus 8e to the 0 minus 5 times 0. That will give us about 59.112448 minus 10 minus 8. So our area is approximately 41.112. Okay, y equals 3x plus 7 and y equals negative 4. And our interval is from negative 7 to 0. So let's look at negative 4 equals 3x plus 7. Negative 11 equals 3x. So x equals negative 11 over 3. So our area will be the integral from negative 7 to negative 11 over 3 of negative 4 minus 3x plus 7 dx plus the integral from negative 11 over 3 to 0 of 3x plus 7 minus negative 4 dx. Simplifying, we'll have negative 7 to negative 11 over 3 of negative 3x minus 11 dx plus the integral from negative 11 over 3 to 0 of 3x plus 11 dx. If we take our antiderivatives, the first one will have negative 3x squared over 2 minus 11x, and we're evaluating from negative 7 to negative 11 over 3, plus negative 3 times x squared (3x squared over 2 plus 11x) evaluated from negative 11 over 3 to 0. And then when we evaluate, we will have negative 3 times negative 11 over 3 squared over 2 minus 11 times negative 11 over 3 plus negative 3 times negative 7 squared over 2 minus 11 times negative 7 minus 3 times negative 11 over 3 squared over 2 plus 11 times negative 11 over 3. There we go. This will give us, if we simplify each piece, we have negative 121 over 6 plus 121 over 3 minus 147 over 2 plus 77 minus 121 over 6 minus 121 over 3, just so that way we don't get a calculator error. So this will be negative 121 over 6 plus 121 over 3 plus 147 over 2 minus 77 minus 121 over 6 plus 121 over 3, giving us 221 over 6, which is approximately 36.83. Okay, number 5 is y equals x squared minus 10 and y equals 15. So the first step is to find where these two functions intersect. And to do that, we'll set them equal to each other. x squared minus 10 equals 15, x squared equals 25, x equals positive and negative 5. So a graph of x squared minus 10 and y equals 15 shows that 15 is greater than or equal to x squared minus 10 on the interval. Let me write this. 15 is greater than or equal to x squared minus 10 on the interval from -5 to +5. So to find the area using the integral from -5 to 5 will look something like this. -5 to 5, 15 minus x squared minus 10 dx. So we'll have the integral from -5 to 5, negative x squared plus 25 dx. Evaluating our antiderivative will give us negative x cubed over 3 plus 25x from -5 to 5. And so we'll have -5 cubed over 3 plus 25 times 5 minus negative 5 cubed over 3 plus 25 times -5. This will give us negative 125 over 3 plus 125 minus 125 over 3 minus 125. So we have 250 over 3 minus negative 250 over 3, which will be 500 over 3. Y equals x squared minus 2 and y equals x minus 5 on the interval from -3 to 2. So the area we want is from -3 to 2 of x squared minus 2 minus x minus 5 dx. So the integral from -3 to 2 will be x squared minus x plus 3 dx. Taking our antiderivative, we'll have x cubed over 3 minus x squared over 2 plus 3x from -3 to 2. And then when we evaluate, we will get 2 cubed over 3 minus 2 squared over 2 plus 3 times 2 minus -3 cubed over 3 minus -3 squared over 2 plus 3 times -3, which will give us 8 over 3 minus 2 plus 6 minus -9 minus 9 over 2 minus 9. So our area will be about 29.167. Y equals 5x plus 7 and y equals 5x minus 2 on the interval from -5 to 3. Our area will be the integral of -5 to 3 of 5x plus 7 minus 5x minus 2 dx. And so we're looking at the integral -5 to 3 of 9 dx. Taking the antiderivative, we have 9x evaluated from -5 to 3. So we'll have 9 times 3 minus 9 times -5, which is 27 plus 45, an area of 72. In problems 8 and 9, use a graphing calculator to graph the equations and find relevant intersection points. Then find the area bounded by the curves. Compute answers to 3 decimal places. Okay, so we have y equals x cubed and y equals 9x. Let's graph those. Okay, here we have x cubed and 9x. And we can see they intersect at -3, 0, and +3. So we want to find the area between -3 and 0, and then the area between 0 and 3. So our area will be the integral from -3 to 0 of x cubed minus 9x dx plus the integral from 0 to 3 of 9x minus x cubed. Let's simplify this a little. -3 to 0 is going to be x cubed minus 9x dx. Integral from 0 to 3 will be 9x minus x cubed. If we take our antiderivatives, we'll have x to the 4th over 4 minus 9x squared over 2, evaluated from -3 to 0, plus 9x squared over 2 minus x to the 4th over 4, evaluated from 0 to 3. And once we evaluate, we have 0 to the 4th over 4 minus 9 times 0 squared over 2 minus -3 to the 4th over 4 minus 9 times -3 squared over 2 plus 9 times 3 squared over 2 minus 3 to the 4th over 4 minus 9 times 0 squared over 2 minus 0 to the 4th over 4. Which will give us 0 minus -20.25 plus -20.25. And so we will have an area of 40.5. Okay, y equals x squared plus 2x minus 3, and y equals -x squared minus 3x plus 4. Let's graph them. Here we have x squared plus 2x minus 3 and -x squared minus 3x plus 4. And we can see that they intersect at -3.5 and 1. So we want the area between those intersection points. Our area will be the integral from -3.5 to 1 of -x squared minus 3x plus 4 minus x squared plus 2x minus 3 dx. Let's simplify a little. We'll have negative 2x squared minus 5x plus 7 dx. Taking the antiderivative, we'll have negative 2x cubed over 3 minus 5x squared over 2 plus 7x, evaluated from negative 3.5 to 1. And once we evaluate, we'll have negative 2 times 1 cubed over 3 minus 5 times 1 squared over 2 plus 7 times 1 minus negative 2 times negative 3.5 cubed over 3 minus 5 times negative 3.5 squared over 2 plus 7 times negative 3.5. This will give us negative 2 over 3 minus 2.5 plus 7 minus 85.75 over 3 minus 61.25 over 2 minus 24.5. So our area will be 30.375.